Hi kids, it's Mr. Josephs here. I'm just going to make a little video to tell you a little bit about what atoms are like. This is not as polished of a video as I normally like to make, but it will do. Okay, so atomic structure. First of all, we know that all matter is made of atoms, and there are different types of atoms. And all the atoms are on the periodic table. And I think I've told you that no matter what you take in the world, you can split it down and you will always be able to fit all the atoms you find on the periodic table. They're already discovered. You're not going to come across an atom that is new. And this is going to become obvious to you in a second. Because you're like, what? Why can't I discover a new atom? Okay, so we can think of atoms as little spheres, right? So here, let's say we've got these spheres. And the simplest atom is hydrogen. And we'll discover why in a second. So I'm going to put the chemical symbol for hydrogen in these atoms, just to represent that they're hydrogen. Hydrogen is normally as a gas, so it's going to be floating around. So it wouldn't really look like this. This makes it look like a solid. All right. So Dalton said that the atoms were solid. This is from the History of the Atom video that you watched, or should have watched, with Professor Dave. And the atoms are actually not solid. So if we were actually to look at an atom, what happens is, let's look at this atom right here. I'm going to change it a little bit. We would find out that in the very center of this hydrogen atom, there's a little particle in the center. We call the center the nucleus. Okay, nucleus is the center of the atom. And in that center of a hydrogen atom, there's something called a proton. And this is a positive charged particle. So you know how you have static electricity? It's kind of like that. It has this charge on it, and we say it has a positive charge. Now, we know that an atom itself doesn't have any charge overall. It's neutral. Okay, so that means there must be something negative in this atom as well. And it turns out there is something negative, and it's called an electron. So the electron, and the electron is a negatively charged particle. And the two of them combined make a neutral particle. Right? We actually call these subatomic particles because they are smaller than the atom, subatom. And this electron is moving around so quickly around the proton in the nucleus that it appears that the atom itself is completely solid. Well, it's not completely solid. It's 99% empty space. Okay, but whatever. We can think of them as solid particles, the atoms as solid particles, because they're moving around so fast. These electrons are moving around at almost the speed of light. And it makes it look like it's a solid. It's kind of like when you see a fan and it's moving around and it's blurred and it looks like the fan is solid, but you know it's not. There's a lot of space in between the blades. But because it's moving so quickly, it makes it look solid. It's kind of the same way. So hydrogen atoms have a proton in the center. They are much more massive than an electron. They are. And then one electron going around the outside. Okay? Sometimes you'll get a hydrogen atom. This is called hydrogen 1 because it has one particle in the nucleus. Sometimes you'll get a hydrogen atom. This is hydrogen 2, and you'll have the proton in the center because All hydrogen atoms have just one proton. In fact, that's what makes it hydrogen. And on the periodic table, it has a number associated with it in the very top. Nope, I'm sorry, in the lower left corner. That number is the atomic number. And there's also, in hydrogen 2, there is another particle in the nucleus. That's called a neutron. Okay? So the neutron, guess what? It's neutral. Neutral subatomic particle. And the only thing it does is add mass to the atom itself. Okay? Again, that electron is moving around so quickly around the outside. You can also have hydrogen 3. Again, only one proton, because if it didn't have one proton, we wouldn't call it hydrogen anymore. It'd be another atom. And 2 neutrons. 1 electron, because we need to make sure it's electrically neutral, and it's negative. This is a negative charge on that, and on the proton there's a positive charge. All right, so that's hydrogen 3. Now, let's move on to a more complicated atom, helium. Now, helium, that has 2 protons in the center. I'm going to make the protons a little bigger and give them plus signs so you can see that. It typically has 2 neutrons, but it doesn't have to. It must always have 2 protons, because if it didn't, it wouldn't be called helium anymore. Now, electrons can sometimes be given with this little E symbol instead of like a dot. So that's what I'm going to do here. And I'm going to say that they have motion around here, kind of put some arrows on them. This is helium-4. And this is helium because it has 2 protons. Its atomic number is 2. And you can see that on the periodic table of the elements. Okay? Now you can kind of start to see why you're not going to discover a new type of atom. And the reason is that, let's, for example, take gallium. How many protons are in the atom of gallium? So if we look at gallium, there'd be 31 protons, and oh my goodness, I am not going to write them all. As soon as you put another proton in an atom, it becomes a different element. And it's not very easy to do that. That's a nuclear reaction. It's not a chemical reaction. Okay? So, oh my goodness, I'm not going to do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 protons there. So that must be what type of atom? If you said sulfur, you were correct. Oftentimes you'll have about the same number of protons. Neutrons. Not all the time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's give it 15 instead of 16. It doesn't matter. So this would be an example of sulfur 31, because you've got 31 particles in the center here. How many electrons must I have going around the outside of this? The answer is I must have the same number of electrons as I did protons, right? Okay, so I'm going to put them here, and we will discover where these electrons go. But there's another ring around it, like this. 4, 5, 6, 7, 8. And then... And then there are 1, 2, 3, 4, 5, 6 here. And that's the atom of sulfur. There is some information on the periodic table that can tell you where these electrons go in which ring. See if you can figure that out. I'm not going to tell you right now, but maybe you can figure that out. Okay. Now, let's talk about another thing. Oh, first of all, let me go back here to this. These different versions of hydrogen, because there's hydrogen 1, hydrogen 2, and hydrogen 3, all having one proton, because that's what hydrogen has, but different numbers of neutrons. We call these isotopes of each other. So if we are going to define something called an isotope, okay, it is different versions of the same atom. So we do hydrogen. I'm going to have, and then my little electron going around. These are my different types of helium. H1, H2, H3. Okay. This number right here, incidentally, is called the mass number. That's because the mass only really comes from the subatomic particles in the nucleus, the protons and the neutrons. They are 1,000 proton, and neutron masses are 1,836 times more than an electron's mass. So we would need 1,836 electrons just to equal the mass of a proton and a neutron. And so that's why we don't really care about their mass when we're talking about the mass of an atom. So that's an isotope. And then you may have heard of something kind of cool sounding. It's called an ion. So what the heck is an ion? So let's use the example of lithium. So lithium, that's used in a lot of your batteries for your phone and electronics, lithium-ion batteries. So what the heck is a lithium ion? So let's draw a lithium atom first. So we know that lithium has 3 protons, and we'll make it lithium-6. We'll have 3 neutrons in there too. And how many electrons do we have? We have to have the same number of electrons as the protons to make this an electrically neutral atom, because atoms don't have charge. And there's one on the outer ring right here too. So this is the lithium atom. Okay? And the symbol is Li. Now, to become an ion, this is going to lose an electron. Lose an electron. So let me get this little bit here. So if it loses that outermost electron, we get something that looks like this. And this is a lithium ion. And ions are particles that have charge. So if we look at this, what is the overall charge on this? Well, we have 3 positives from the protons in the nucleus, and we have 2 negatives from the electrons that are left over. So the overall charge on here is positive, and we represent that like this, Li+. So that's the lithium ion. That's if an atom loses an electron. But atoms don't have to lose electrons. Atoms can actually gain electrons as well. So how about we look at an example like that? Okay, so this is a positive ion, but we can lose electrons. We can gain electrons, sorry. So let's look at something that gains electrons to become an ion. So the ion, remember, is a charged particle made from a neutral atom gaining or losing electrons. And some atoms will gain electrons naturally and some will lose electrons naturally. So let's look at an atom of oxygen. Oxygen has 6 protons in the center. That's its atomic number. And we'll do oxygen 16. 1, 2, 3, 4, 5, 6, 7, 8. All right. And then we'll put some electrons around it. Whee! How many electrons? If you said 6, you're correct. You might notice a pattern here. The innermost shell fills up with 2 electrons. Okay. Wait a minute. Did I make a mistake? I sure stinking did. I made carbon, didn't I? I need to make some more. 1, 2, 3, 4, 5, 6, 7, 8. All right. All right. Good catch. All right. So there we go. There is an atom of oxygen. Now, we will explain why in the future, but this is going to gain 2 electrons. Okay, so I'm going to copy this atom over so I don't have to redraw it. And we will add 2 electrons to this outermost shell. Now, because we've added 2 electrons, we have 8 positives. We have 10 negatives from the number of electrons now. So the electrons win, the negatives win, and we call this an ion of oxygen. And the symbol we use is the symbol for the oxygen atom, capital O, but we put a 2 minus at the top, or a -2 at the top, and that tells us that this is a negative ion, and we've gained 2 electrons. Now, negative ions, they are called anions. Anions. I had someone call that an anion before, because it looks like onion, but with an A. But it's not. It's an anion. And then positive ions. Those are called cation And I don't know why they're not, the other ones aren't called dog ions or something like that. The same person that called the anions anions, they called those cations. But you know what? They were being difficult. That's okay. You can be difficult. But it's a cation. All right. So that is about it. I'm going to give you another video to watch from Professor Dave that can help you out as well. All right. Have a good one.